Hello everyone, my name is Reza, founder of the optimizationct.com. In this video, we are talking about the basic of the primal simplex methods. Let's go.
So let's get started. The primal simplex method is the algebraic method used to solve the linear programming problem. It's easier to work with equations that are equal rather than inequality. So the first step of this method is to convert the functional constraint from an equal form to an equal one. The constraint of the constraint of the negativity can remain inequality to an equality can remain on equality because they don't directly affect the solution process. To convert an equality to an equality, we introduce slack variable. To demonstrate how the simplex method works, we solve an example. Here we have three constraint and two variables. We are going to maximize 3x1 plus 5x2. So let's look at the first constraint. X1 is less than 4. We can define the slack variable x3 as a difference between right-hand side and left-hand side of constraint 1. This allows us to write constraint 1 as an equation that's equivalent to original constraint as long as x3 is greater than or equal than 0. This gives us the following set of constraints. So we added three variables to become the inequality constraint to equality constraint. To help illustrate this concept, let's consider the simple example. If we have constraint 1, x1 is less than 4, x1 has a value of 1. If x1 is the value of 1, then the slack variable would be equal to 3 because summation of x1 and x3 would be 4. We can rewrite the constraint as x1 plus x3 is equal to 4, which is equivalent to x1 is less than 4 when x1 is 1 and x3 is 3. This process can be applied to other inequality in these constraints. We have two other inequality constraints, which allow us to rewrite the entire model as necessary. We will discuss in future. We call x3, x4, and x5 as a slack variable. Model MP1-1 is essentially the same as the model P1, but it's been simplified to make an algebraic operation easier. In P1-1, there are 5 variables and 3 constants, which means that there are 2 degrees of freedom. It means number of variable minus number of constants. To solve the system of equation with 3 variable and 3 constraint, we will set the desired variable for 2 additional variable in each step. In the simplex method, these additional variables are set to 0. Variables that are set to 0 are called non-basic variable, while the other called basic variable. The solution where all non-basic variables are equal to 0 is called the basic solution. And the basic feasible solution is the basic solution where the basic variables are non-negative, that we call basic feasible solution. We will use this term in future, more common. In this model, we can easily identify the basic variable because each equation has only one basic variable with the coefficient of 1, and this variable does not appear any other coefficient. So we can see that x3 is the basic variable and does not appear any other coefficient. To simplify the process of solving the problem, it's helpful to rewrite the objective function as a functional constraint and add it to the list of constraints with the row of 0. Before introducing this simplest method, we rewrite the problem P1-1 in this way. So we have P1-2 is a final model for entering the Primal Simplex model algorithm. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by form by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.